via a Zoom connection, which would be that one, from across the country.
It's delayed. We're really fast.
Okay. There are folks from Brown, Duke, Notre Dame, MIT, a small place near the Charles River in Boston, Fresno and Northridge here in the state and elsewhere. All of you zooming in are most welcome as well. If those of you who are zooming in have a question during the Q&A time, please use the chat feature and we will do our best to address your questions. Several years ago, maybe 3 years ago, we were introduced to the possibilities, actually the realization of the possibilities of AI through the licensing of a service called Discover, which had a greenhouse period here in this building. Discover is a conceptual discovery environment. It's accessible through the Stanford homepage. It's already proven to be quite a successful and quite different way of discovering possibly relevant information, possibly relevant documents through a very different interface than anyone has ever seen. About a year ago, a little more actually, I think, we began here in the libraries to explore how we might incorporate new technologies associated with artificial intelligence in our internal processes and how we might apply them to better serve scholars here at Stanford and perhaps elsewhere. We have already incorporated machine learning, natural language processing, and computer vision into applications like EPAD, the software package developed by our special collections and university archives that supports the appraisal, ingest, processing, discovery, and delivery of email archives, and in collaborative projects with faculty, always with faculty, through the Library Center for Interdisciplinary Digital Research. Our AI initiative is an opportunity for librarians and staff throughout our system to become familiar enough with machine learning and neural networks to imagine how this technology might support their own work. We took advantage of our proximity to Silicon Valley and our own computer science department here at Stanford to host informal conversations with experts in the field. In July of this year, we launched the Stanford Libraries AI Studio as an opportunity for staff to bring up projects, engage them, and get some hands-on experience with the new technology. And as I say hands-on, I really mean brain-activated engagement with the new technology. Nicole Coleman, who is our speaker today, heads up this effort and has and continues to do remarkable work with her colleagues around and about. We are launching information, intelligent machines, and new knowledge today to encourage a wider discussion about the opportunities and implications of these technologies. We're kicking off the discovery sessions with Nicole's talk, but we will also be hosting a presentation on the 26th of November by Ruggero Grammatica, CEO of the discovery environment I just described. He will share the work his group has done with machine learning, neural networking, and AI to produce the first interdisciplinary knowledge graph. To conclude the discovery sessions track, teams from the Stanford Libraries AI Studio will share the results of their experiments on our library collections in January. In February, our dialogues track will include Stanford faculty discussing hotly debated topics in artificial intelligence, data science, and the ethical issues of information access and digital mediation. Follow us on our Facebook and Twitter accounts or join our newsletter Remix to stay connected to all that will follow with this series. Now, it is my pleasure to introduce Nicole Coleman, who has been with the Stanford Libraries for 15 years. You will note that she must have been 15 years old when she started to work here. However, she's a very advanced student and has done quite well over these years. She worked for several of these years in our Academic Technology Specialist program, and in that role, she worked in close collaboration with faculty on grant-funded data-driven projects in the humanities, eventually co-founding the Humanities Plus Design Lab at the Center for Spatial and Textual Analysis. Now, as digital research architect within the Digital Library Systems and Services Group, Nicole works at the intersection of the digital library and digital scholarship as a lead architect in the design and development of digital library services in response to the research needs of scholars and, of course, students. Nicole, podium's all yours. Thank you all for coming.
All right, there we are.
There it goes.
Okay, so we chose this image intentionally. A lot of AI conferences and meetings have pictures of, artificial brains and things like that. But here within the library, we really wanted to focus on what AI means in the context of the digital library, digitization that we've done, how it might help us actually manage content much better and make use of the data that we already have available for discovery and for analysis. Over the last 20+ years, governments, funding agencies, and institutions have committed tremendous resources to digitization, ensuring that the knowledge held in libraries can be a part of the information ecosystem. Having moved the library catalog to the World Wide Web, the initial goal of digitization was to make content accessible via the web. But Philip Skur, our Associate University Librarian for Technical and Access Services, has pointed out that when we moved the catalog to the web, we merely created a digital version of the same data model. Though what was needed was a total redesign of the data model that aligns with the network structure of the web and takes full advantage of the affordances of that model. The Herculean effort to re-architect metadata development and exchange on this graph model is underway here at Stanford as linked data for production. In 2011, the Bodleian Library, the British Library, and Stanford University Library, here nearby at a little restaurant, conceived a model for a digital image delivery system that works in concert with the linked open data model and releases digital content from the institutional silos, or what they call the walled gardens of technology. That vision became the International Image Interoperability Framework, or IIIF, which is now a mature community of international partners. The image and presentation APIs make it possible to build virtual image collections at will, bringing together content housed in very disparate geographic locations as if it were on your local machine. Digital library and archive projects are also essential to entirely new fields of study that have emerged in large part because of the ability to engage with collections computationally. Researchers are mining text to identify entities, uncover networks, look for patterns, and measure features. To support this growing interest, the Institute of Museum and Library Services has funded Collections as Data, an international effort to develop a strategy and framework for cultural heritage institutions that want to develop and provide access to all kinds of digital collections for computationally driven research. So in a short period of time, we've shifted from thinking of digital objects as electronic photocopies to discrete, well-described objects that can be exchanged over the internet. More recently, we're treating them as objects that contain data that can be parsed and analyzed at scale. But artificial intelligence, and specifically machine learning and neural networks, or deep learning, are radically changing how we engage with digitized materials. Just as the World Wide Web influenced the architecture of data services and the delivery of content, the successes of artificial intelligence in the past few years indicate what is widely believed to be the next big inflection point, bringing changes with cultural, social, and economic implications more profound than the Industrial Revolution. So when I started as digital research architect, I was mandated to look at how digital research practices are changing across the university. So what I did is I interviewed faculty. I also interviewed our bibliographers, our curators, people who are, and our academic technology specialists, people who work directly with faculty to better understand what that looks like. And one of the big things that came out of that was they use Google, which seems very simple, basic, and obvious, but it's actually really quite profound because Google is essentially AI, right? It's AI with a lot of data and an interface. Of course, they use Google Books as well, Google Scholar, and soon, probably Google Dataset Search, which was not available at the time when I was doing those interviews. But for us, the concern is that Google is fast, right? But it provides no context, or as my colleague James Jacobs says, it's a swamp. So Stanford faculty were saying, look, this is what we do, but this is what we need. I need more recommendations from my librarian. I need help finding things. I need print documents, audio, etc., whatever, fill in the blank, available for computation. Yeah. And when I talked to librarians, what I heard was, we need natural language processing tools for collection building. We need more metadata. We need digitized material made discoverable in the catalog. So when we think of Google's fast, but provides no context, Google's weakness, of course, is our hidden strength. Carefully curated content and expert human-powered discovery system. So Google search is data plus AI plus interface. I'm saying let's give librarians data plus AI plus interface and see what they can do. So as Mike mentioned, we started the Library AI Conversations group at the end of last year. We were fortunate to be in such close proximity to Silicon Valley, but also to have this extraordinary knowledge within our own computer science department. So these are some of the people we spoke with. What we learned, first of all, is machine learning is utterly different than classical programming. And if this is a model, take for classical programming, we have data, we have rules, program, come out with answers, right? I mean, those rules essentially being the code. But with machine learning, it's going to be the other way around completely, right? We start with data and answers and try to figure out the rules. We deduce the rules based on those answers. Second lesson, machine perception is entirely different than human perception. Greg Corrado from Google Brain was just speaking at Stanford Neurosciences Institute recently, and he said that we call them neural networks, but they have nothing to do with neural architecture. So what do they actually do? Just so that we have a kind of level setting for this group, in case you're not familiar with the process, this is a very, very basic example of taking handwriting and running this through neural network to be able to identify. So we take a data set like this, a bunch of different, each one unique handwritten numbers. In this case, I'm selecting 4 out of that, right? So I've got my starting set, and that's it. I'm going to work on to try to discover those. I'm going to play this very short animated piece from Grant Sanderson because it's really captures it.
28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit.
So hopefully that gives you at least a basic idea if you're not familiar. That machines are seeing objects not the way we see objects, right? Holistically in their entirety. But we're really just talking about processing numbers. And in this other example, you can sort of see this neural network, you get the idea, looking at a face. The face is really essentially, numerically, according to pixels, a collection of edges. We can see those edges in combinations start to form shapes, familiar and recognizable shapes, right? And build object models from that. It works very much similar way with text. We can vectorize an entire text, right? Like turning each word into what is essentially a set of numbers, a vector in vector space. And the kind of results that we can get are quite extraordinary. You see here on screen. So we can understand relationships between words in vector space such that king is to queen as man is to woman, for example, or walking is to walked, as swimming is to swam. And you see these examples too with these concepts like country and capital. Those relationships are things that can be mapped and understood. So the third lesson of this is human perception is biased according to task, training, mood, experience, preference, etc. Machine perception reflects the bias in the data. Londa Schiebinger was also part of our library AI conversations group, and she published this article, Word Embeddings, Quantify 100 Years of Gender and Ethnic Stereotypes, with Dan Jurafsky, James Zhu, and Nikhil Garg. And one thing, it's a paper we should read, it's fantastic. The thing I wanted to point out here is, Londa is an historian, and as soon as we started to recognize that, oh, we're running all of these models on the same big collection of vectorized corpus, and what we're getting is we're starting to see bias. Well, naturally there would be bias. But one of the things that Londa did on this project is actually break that down and show historically the significance of those changes. So in this case, what you see, the top Asian versus white adjectives in 1910, 1950, 1990. So she's relating those to significant historical events or periods and time. And I think one of the interesting things is that historians, like librarians, understand that there's going to be bias in a data set. That's just a given. Here's another paper, this by two researchers from Facebook AI Research, and they were using ImageNet. ImageNet is another, this is a big image database that is the benchmark for so many of these tests, and starting to see bias in that data set. So for example, this image came up labeled as basketball. Now, they said, we thought the problem was that the class basketball only contained pictures of Black people. But no, the class contains as many pictures of white people as Black people. The bias appears because Black people are underrepresented in the data set as a whole. Okay. So this is important to recognize the limitations. When you're looking back on data and using data sets, of course, all of that data will be inflected by who created it, how, and so forth. So lesson 4 for us is, while bias in archives and collections is not news to librarians, we need analytical tools to help us see, record, and describe that bias for researchers, right? So in other words, we can turn this around and use this as a beneficial way of describing our collections. Okay, so Soul AI Studio started in July. I'm calling it a Silicon Valley startup story, simply because we really didn't have any funding for this. Everybody was working within their free time, or making time and finding time to do this. I did my best to learn Christina Harlow's recipe for a cold brew, provided donuts, but we didn't provide lunch. People just gave up their lunch hours to work on this. Nonetheless, a lot of my colleagues participated in this, which is really, really terribly exciting. So the first thing we did was work on surfacing needs. And the kinds of things that came out are like this. So Amanda Whitmire, who's the librarian at Miller Library, Hopkins Marine Station, had this data that she'd been working with. It's essentially analog data out of which she wants to be able to extract, or analog papers out of from field data that had been captured in the last century. She wanted to be able to extract this information so it could be used. Right? Now, this is essential not only because this is really, really important climate data. We don't have data, granular data like this, right? So it's very important for research. But it's also important for Amanda because the Miller Library is in a tsunami zone, right? And if this gets wiped out, it's gone. If we can make digital copies, we can extract this data, we can use it. Okay, and then Claudia Engel, much more or less, academic technology specialist for anthropology. She's been working for several years with Ian Potter on this big project, the Telefeuille Archaeological Project. And over 20 years, you might imagine on site, they've gathered a tremendous amount of data. There are field notes in the way of recordings, there are handwritten notes, there are typed notes, and there are lots and lots of photographs, right? So for this project, the idea was to let's just start with just the photographs, about 140,000 photographs, and see if we can actually make sense of them. You know, I think most all of us who have collections of images on our laptops or whatever know how hard it is to manage images, right? There was no standard way of managing these images. So you have to go back and see, can we extract meaningful data from these so that we can start to make sense of them, at least make them more discoverable, more navigable. And so this image doesn't quite show it, but this gives you kind of an idea of the sort of simplicity of the kinds of images you're working with. But there are images in the collection that have whiteboards. The whiteboards were used to make handwritten notes describing that scene, right, as a way of documenting it. So now what Claudia has been doing, working with her colleagues and with Chris Shute at the Stanford AI Lab, is using computer vision to recognize, first of all, which images have whiteboards in them, right? Then once we can make a subset of images that have whiteboards in them, read the handwritten text. See if we can actually read that and figure out what's going on in those images. And then we can find related photographs. Another project, this is within special collections. So Salih Bosch is leading this project. It's going from speech to text, right? So getting data from audio. We have Stanford Libraries holds this wonderful collection of Allen Ginsberg papers. A significant amount of that collection are recordings. Bob Dylan gave him a tape recorder, he carried it around with him, and he recorded all kinds of things, right? And we have students now here working, specifically coming to Stanford to work with this archive. But they have to sit and listen to hours and hours and hours and hours of tape. If we can convert speech to text, then we can search that, right? And there's also other ways of finding these really key moments within those tapes, within those recordings that make them much more useful, again, more navigable. And Peter Montevico, I'm sorry, I misspelled his name, has been working on this as well. This gives you an idea of the kind of recording. Very complex, multiple voices. We ran this sample through Google's API for speech to text. And Sally was blown away at the accuracy. It's not perfect, but it gives us enough, more than we had. So the lesson here is that digitization is essential, but not sufficient. Right? And we digitize things, but until we can extract more information from them, they are often not usable to us. In fact, we could say that in some ways, things that are digitized for which we do not have adequate metadata or any other ways of discovering them might as well be lost in the archive like so much of our physical materials are. Okay, so library-inspired AI in practice. So I wanted to take you into some of the kind of inner workings of what we've been doing in Soul AI Studio. One first lesson, teach them to fish. The idea here is that actually, by starting this team across the library, right, with people who, as you may mention, in special collections, in archives, bibliographers, people who are completely unfamiliar to this. The technology can be very simple, right? So as I said, Google has these APIs for speech to text, Amazon, there are a number of them out there for image recognition, that sort of thing. We can learn to use these, right, without there being a really big learning curve up front, right? So this means we can distribute and let that technology be available to many different people. In this other example, so this is a project on image classification. This was interesting. Right? It started, Jack Reed had this idea that, oh wait, look, if we throw this image up at the Google Cloud Vision API, we get a bunch of results, and you see that on the right there. Labels, right, describing what's going on in this image. Wow, that would be pretty amazing. What if we did that for all of the public content in the Stanford Digital Repository? Could we get some useful information out of that? And he had also in his mind with that, well, and what if we could use that as part of as kind of a workflow with the International Image Interoperability Framework to make images more discoverable. But what happened there is, as we got together, so Jack Reed, Chris Beer, and Jesse Keck are all engineers working within the Digital Library Systems and Services team, and they saw a way to basically integrate this with our existing infrastructure and build something that could actually be really, really useful and practical, right? Whereas Josh Schneider, Peter Blank, and Hillary Thorson, not impractical people, but really were inspired to think like, well, what might we be able to do with this technology to delve into these image collections in different ways, right? That are not limited to the kind of labeling that we see here, that tends to be oriented much more to a commercial purpose, right? These are models to serve a commercial purpose. That's what they were built for initially, right? So for example, you know, maybe we could instead build labels that are more appropriate specifically to libraries and archives and museums, things that would help us better understand what would an ontology look like for that particular collection, right? Or maybe we just bypass metadata altogether. What if we could just match an image to another image, or match an image that's similar to another image as a way to help us discover, right? Interestingly, Hillary Thorson, who's in metadata development, said, well, that would actually help me create metadata, because if I can do copy cataloging. If I can match an image against an image, similar image or the same image in another collection, I can use that. So lots of different ways you might be able to apply this. The lesson 2 here is that context switching is really difficult, as is culture shifting, right? The change is not about the skill set, it's only, right? It's also about a change in process. What I mean by that is when we're trying to do AI within the library, but we've been working in a really different way, people are accustomed to, like Jesse and Jack and Chris, building our really key infrastructure, are going to see that as the best way to use their very limited time. We were under significant constraints, as I mentioned. They have like 2 hours a week, right, to work on this. So they wanted to have success, right? Whereas for our folks in archives and Peter Blank, who leads our entire photography collection, it was, how can we do something new and different? Okay, next project, 19th century novels. So Rebecca Wingfield, who's curator for British and American literature, she brought this project forward. There are 1,600 novels. She refers to this as the great unread in this collection, meaning we have very little metadata for them. And that meaning, as a result, trying to look for these novels in search works doesn't give you much, right? It's very, very difficult to find them. So in this project, Rebecca is working with Arcadia Falcone, who's also from our metadata department, Javier De La Rosa, and Scott Bailey. So Javier and Scott are both developers in CIDR, the Center for Interdisciplinary Digital Research. So the problem for this project is, as I said, the works are essentially unknown to the field, so there's very limited metadata. But what we wanted to do is see, like, are there features in the corpus that could be used as metadata to make novels more discoverable and navigable? Now, what Javi and Scott said, leading the development side of this, okay, but success requires the team to work closely together in a cycle of evaluation and adjustment of the model. So like I said before, it's a really different model than classical programming, data and answers. If we're going to start with the answers, that means we've got to start up front and through the entire process with domain experts. So in this case, Rebecca and Arcadia are the domain experts. So number 2, we had no plan to actually implement the results into our discovery environment, SearchWorks, if the experiment was successful, right? Well, Scott and Javi are both very scrupulous, conscientious guys, and they're like, why am I going to waste my time with a process that isn't actually going to produce meaningful results? And then third, someone, in this case it would have to be Rebecca, would need to read many of the novels in order to label them, right? To provide that labeled set against which we then try to match other novels. Okay, so first Everybody agreed, yes, we'll work together. And that was a different model than the 2 hour at a time. This was, we're all gonna put all of that into one chunk, work together and see what we can come out with in a limited amount of time. Number 2, this is really an important shift in our thinking when we talk about working with AI. So no, there's not a plan to implement results into our discovery environment, not in the short term. If it's successful, maybe we'll launch a whole program to do that. But Rebecca is also part of our discovery environment. It's the human discovery environment, as I mentioned, meaning faculty are coming to her, students are coming to her looking for things. If she can at least learn more about this collection through this process, she will be able to pass that on. She'll be able to make use of that. All right, and then the idea that someone would need to read many of the novels. Now that is a thought that Scott and Javi had because their frame of reference is working with faculty on research projects, right? Very, very important to be extremely diligent about what you're doing, what's the process, what are you actually looking for, what are the patterns. But Arcadia explained that for catalogers, they don't actually read entire novels to develop metadata, right? So we've got a different method when we're working within the library, building tools for librarians to support research. So AI for librarians is not the same as AI for researchers. We're not doing interpretation, but a kind of dimensionality reduction and exploratory analysis. Also, this is just sort of running through all the project pre-process. It takes a lot of time. Library digitization practices aren't designed for computation. That's where collections as data comes in. Okay, now I want to sort of change gears a little bit, and since I'm the digital research architect, I'll talk a little bit about architecture itself. So Anne Burdick did this study on the library as an indexical landscape. So I'm going to conclude with this as kind of meditation on libraries as physical spaces. So while physical spaces don't change as quickly as digital technology, it's instructive to look at how library buildings are being reimagined to take on the affordances, the opportunities, and challenges of new technologies. So when Anne Burdick investigated these libraries as indexical landscapes, she's referencing Shannon Matern's notion of physical spaces as algorithmic places that gather and process data as we move through them. So the first of these she looked at is the Seattle Central Library. It's organized around the Dewey Decimal System. Space is laid out in what the designers call a book spiral, a continuous flow from 0 to 999. To emphasize this organizing principle, the classification system is embedded into the floor itself. In another part of the library, I was wondering what happened in 960. In another part of the library, the floor is made of relief letterforms that, in the word of the artist, seeks to mark this moment of technological transition by embedding in the membrane of the library's surface work that in texture and form remembers and evokes a tactile experience of book production and reading. So taking a very different approach, the 3.5 million volumes in the Joe and Rika Mansueto Library at the University of Chicago are organized via storage algorithms, hidden underground, mechanized. Above ground, all you see is a submerged egg-shaped dome next to the Regenstein Library, which holds 4.5 million print volumes. Rather than walking and browsing in the flow of books, as one would at the Seattle Central Library, patrons of the Mansueto Library request books online, which are extracted in boxes of 100, identified by barcodes, and then selected by human library workers. Finally, Burdick takes us to the Sitterwerk Kunstbibliothek in northeastern Switzerland. Comparatively tiny holding of about 25,000 books, Sitterwerk uses a dynamic ordering system that reflects the idiosyncratic nature of the collection and the collector, Daniel Rohner. The library was originally Rohner's private collection, and he enjoyed rearranging the books and making little subsets. So when they made the library public, they decided to give that agency of rearranging the books to researchers. So visitors can organize or disorganize the collection as they wish during the day. At night, something magical happens. The new positions of the books are recorded and automatically updated in the online catalog. As the Sitterwerk resident tells it, the guest room was literally beside the row of books. And I was able to watch the mini rowboat doing its work during the hours the library is closed to the public. On the first night of my stay, I was woken up by its mechanical sounds. I sat in the dark watching it glide across the shelves, glowing green light and emitting a laser point to scan the RFID tags within the book. Each one of these examples of ordering and managing physical materials probably evokes some unease, perhaps for different reasons in each one of us. But Bernie's concern in her study is redesigning physical space in response to new technology without reimagining the online interface to library holdings. Okay? Citawork is the exception of these three examples. So Citawork uses machine and interface in response to our needs and desires, rather than dictating how we engage. That's how we want to reimagine interface to take advantage of the affordances of AI. When Peter Norvig from Google came to meet with us, he essentially said, we've developed incredibly powerful technology, but we don't yet know what questions to ask. But within the library, the questions we want to ask and have answered come through all of our staff who work directly with students and faculty. Google's search products have already changed expectations. People are no longer satisfied searching for books. They want to search within books and follow citations and connections across books. It's seductive in its availability, simplicity, and apparent comprehensiveness. But within the library, we know that Google's access to information is not comprehensive. As Rose Harrington reminds students, we didn't give Google everything. And perhaps, even more importantly, the flatness of search in that mode is dangerously deceptive. It's biased, and the bias is not revealed. There's no context, or that context is hidden within a search algorithm that the results of which even Google cannot explain. AI is a set of techniques for processing information that can be extremely powerful, but to a significant extent, untamed, untethered, even out of control. I believe that these techniques married with curatorial expertise provide an opportunity for libraries to design powerful new instruments for information management, information processing, discovery, analysis, and curation. AI is not necessarily about doing things differently than we've done in the past. It's about automating the things that are easy for machines and difficult for humans so that we can turn our attention to the creative aspects of our work, to designing systems that are more responsive to the way research is done today.
Hi, my question is about interpretation. How far is machine learning how far are we away from that can be really used for researchers to understand data?
Well, we are actually hosting a series, a dialogue series where we're going to be bringing together experts in the field of AI with our faculty in the humanities and social sciences to talk specifically about things like that. Right? So that's beyond the scope of what we've done, because that's not really the business of the library, to be doing that. But those are really, really important and interesting questions for us to be asking.
I have one from a Zoom participant. How can libraries digitize content ready for computation?
So for that,
Can you repeat the question?
Oh yeah, how can libraries digitize data or digitize materials for computation? It's challenging. Digitization is already a challenge, but I think in the examples that I showed, one of the things that we can do is start to use AI to extract more data. Right? So we're already doing OCR. We have a massive OCR process here at Stanford. But wow, now we can start to OCR essentially recognize handwriting, right? Not just printed text. If we can transform, for example, these audio files, right, into text, that makes them more accessible. But the kind of problems that I was pointing out are also that we use formats, right, that are intended for storage. So when we OCR text, we might have that text then broken down into a number of different subfolders and zip files and that sort of thing, right? But when you're building a corpus to do analysis, you need to be able to bring all of that stuff together. There's a lot of pre-processing involved in that. And there's a lot of suggestion that, especially as these corpora get bigger and bigger and bigger, it really is going to be necessary for the library to play an important role in the dimensionality reduction. So we have too much data. Right? We're awash in data. Some might say we're drowning in data. But we have too much, right? But when we vectorize these books, we create so much more data. We need to be able to break that into manageable chunks for research and analysis. But check out collections as data, right?
So there's another example, and it's in the area of healthcare. Stanford's hospitals have about 2 billion radiological images. And there could be many new possibilities of understanding what's going on in these images if we're able to analyze it as a collection of images. The radiologist can identify with great precision the answers, the categories of findings in, say, a few thousand of these images. Then the machine learning takes over and the sort can occur, and then iteratively quality control can be applied, and anomalies can be identified, and then human attention brought to those anomalies. This would turn a 2 billion image collection into a research project that would begin to widen our understandings of what the possibilities are for using these images for diagnosing various symptoms, not simply the ones that were originally thought of.
Mm-hmm.
It's an obvious possibility, and ironically, of course, the IIIF lends itself with AI and machine learning to that solution set.
Yeah, absolutely. Yeah, it's just fascinating to see almost day to day more that's being discovered. So we did work with Matt Lundgren in radiology at Stanford, and that was sort of our connection point to the Stanford AI lab, and Chris Shute, who Claudia is working with. But there's this, I mentioned Greg Pareto, a quote from him from the Neurosciences Institute. So he was sharing results of a recent paper where they were looking at retinal scans, right, to see how well AI could do at recognizing a diseased retina. And what blew them away is that it went far beyond just recognizing a diseased retina. It could actually tell things like, from a retinal scan, gender, whether or not the person's a smoker, body mass, all these kind of details, right? So if you see that machines are not thinking like we are with all of the kind of complications of context and requirements of very specific training, or the limitations in some ways of specific narrow training, but just looking for patterns, can find patterns that are so much more subtle and things that we didn't even recognize were there. Yeah.
So how do you see sort of the role of the library evolving, right? I mean, the role that's played throughout centuries is sort of like a little bit similarly, somewhat, I mean, not here maybe in the institution of Stanford, but just generally like the library. How can we disrupt the library itself to empower people again, give value back?
Well, Stanford is absolutely disseminating information as well. I think we're going to wait and see. I mean, I'm expecting those answers to come from all of the people in this room. I mean, it's still really, really early days. But as I tried to, the point I would try to make is that when we sort of pry information out of context, we're losing, really losing sort of access to meaning. Right? And one of the things that we have within libraries, let me step back and be like, a lot of the work that's being done in AI is about understanding human intelligence by putting it in relation to what we're calling machine intelligence. Right? So if as we begin to understand more about the extent and the limitations of our own intelligence, we would naturally naturally want to look at the library that houses knowledge, and knowledge that is categorized, right? And it's already been gathered and organized. We can look at the knowledge graph specific to particular libraries, specific to different subdomains and fields, and also see how those are evolving over time. Gives us a tremendous amount of insight into how we build knowledge and how we think about disciplines and what that ends up meaning. Other questions? Right. Oh.
When you were talking about the Google being the data and the AI and the interface,
Uh-huh.
that you want to give those elements to libraries, can you talk more about the interface element? With Google, the appeal is that the interface is
Yeah, that's true. Is it kind of outside the scope of this talk, but I'll show you a kind of example that I'm thinking of. And no, this doesn't have anything to do with AI specifically, right? But the work that we do with AI needs a way to sort of come out, right? And AI has made great leaps and bounds in the last few years. I mean, the ideas, the underlying ideas, the underlying math has been around for a long time, but it was the fact that we had now enough data, that we had enough computational power, right? So all these things kind of converge at the right time. Well, something else that's been happening that's really significant in the last decade or so is a really, really major change in online graphics, right? I mean, this has happened right here at Stanford. So what I'm showing you is a very simple interface built on the Dewey Decimal System, right? So the idea for this was put it right on the top of the catalog page as a way for people to navigate. But it's not only for navigation, right? Because often we come and we're looking for a particular book. But what it does is it even peripherally gives you context, right? It gives you a sense of the distribution of content, right? And this is one of the things that Rebecca Brunel asked for early on in our AI lab. It's like, well, can you give us a better picture of what the content is we have within the library? Now, this is a very simple example. I don't mean this as an answer, but this was also as the librarian of the University of Technology of Sydney, where this lives, said, really inexpensive too. This came out of an artist designer in residence program that they hosted at the library. And it's a wonderful opportunity for a designer because they got all this material and data to work with. And that's what they came up with. It's a really fun and fantastic project. And you can see where, something like that would be a great answer, an interface answer to the Seattle Central Library, right? But it would also be very effective for the Mansueto Library, because in fact, one of the reasons this was necessary at University of Technology of Sydney is because they, like Mansueto, use that same kind of RFID tagged, mechanical storage for their books. Other questions? All right.
Thank you very much.
Oh, sorry, Rebecca.
Yeah, you said something that I just thought it would be fun to hear more about. You said something about librarians do the domain reduction. I couldn't take notes fast enough and think about the
exploratory analysis. So I talked about dimensionality reduction.
Dimensionality reduction. What do you mean by that?
What I mean is, so I, in my former incarnation within the Humanities Plus Design Lab, worked on a research project with Dan Elstein here, where what we were trying to do is make available to researchers linked data, right? The kind of whole environment of world of linked data. And so you could essentially like draw a graph and start to build data by choosing someone like, maybe in Dan's case, Voltaire, and expanding out of a name to, okay, let's match Voltaire, this name, against an authority. Let's match him against the other. And if we can match him against the virtual international authority file, then we can pull in all the related data, all his publications, that sort of thing. Well, so we use VF, we use geonames for places, right? Because in this particular project, we started looking at correspondence. 17th and 18th century correspondence. So we wanted to understand place, people, relationships, letters, that sort of thing, and publications. Well, it was too much, right? The data mass is really, really way too much, right? So you have to be able to reduce that to a more reasonable amount just so that it's manageable to work with. So that's essentially what I was talking about. And then in terms of exploratory analytics, the techniques in AI are being used. So if you run unsupervised learning with no prior models on an entire collection, that was one of the kind of big breakthroughs where they were able to identify a cat, right? And that was Andrew Ng's group. But the reason the way they were able to identify a cat was, as he said, he had almost an infinite amount of images to draw upon. So then let the machine classify all of these different, not classify, pardon me, just cluster, identify, right, patterns that are similar and cluster all of these different objects. And so they were able to say, okay, now I give you a picture of a cat, can you find a match for that? So that's often used, though, as a first step in dimensionality reduction. We start with clusters. Now let's build some really meaningful categorizations, classifications out of that. Right? Those are steps that I think would be extremely beneficial for us within the library. Okay.
I'm visiting from the University of Technology, Sydney.
Oh, wonderful.
And we have another layer to that, the color band, the shelf view. You go at a more granular level.
Okay.
You can look at the books as if they were on the shelf.
Wonderful. Yeah, we have that too. It's fantastic. But thank you.
And that's part of the
And welcome.
artist in residence
Yes.
project.
Yeah. There's another project in part of that too, which is actually kind of fantastic, that shows the activity of books coming in and going out of the library.
We have that in the lobby where it keeps continually showing.
Yeah. So precisely because the books are essentially all hidden, but at the same time you have the advantage that they're recorded, right? So we have a record. There's RFID tags. They have record of books coming in and out. So we're able to actually visualize that, which is wonderful. It doesn't necessarily serve, a very practical purpose, but it inspires and explains to people kind of, oh, this library, this is a very dynamic place. There's a lot going on. It's very quiet, but there's a lot.
And we have two things. One that says books that I loved, and the others. So as you return it, the RFID picks it up, and then you can display on the screen the books that people love.
Yeah, nice. Very good. Yeah. All right. Well, thank you so very much for coming.